Okay, there. We are now going to work on factoring linear expressions. Okay, this is in chapter 5 and lesson 8 of your textbook. So if you ever need some more examples to look at, there are plenty of examples of there. Okay, and this is going to be basically doing the backwards of distributive property. So what we've been doing for the past few days, you're going to do the opposite now. Okay, so our objective is that I will factor linear expressions. What we already know that built on top of this is simplifying expressions by distributing and combining like terms. Remember, like terms mean they have the same variable to the same powers, or they are constants with no variables. Okay, our distributive property, we multiply the number outside the parentheses to each term inside the parentheses to get a simplified expression. And you need to know how to do this. So when you get into 8th grade next year, you can factor and solve quadratic equations. And you might even do those more in 9th grade. Okay, but this is where, once again, 7th grade math builds the foundation of what you need for the rest of your math career. And that's why we keep pushing you to make sure that you are doing the hardest that you can and staying on top of doing your schoolwork, because it really is going to be important later on for you. Okay, so if you are filling in your organizer, this is your 26th page titled Factoring Expressions. You're going to glue it in right after a distributive property notes. Okay. So if you got your notes, go ahead and get those out. If you were in class yesterday, you are filling these in. Okay. If you're a virtual student, you might need to print this out and then fill it in as you go along, or fill it in your notebook by hand. Okay. Factoring expression notes. So let's activate our prior knowledge. What is this building onto? A number that divides into another number exactly and without leaving a remainder. That's what a factor is. Okay, we've talked about factors before. They're different than multiples. Okay, these are the numbers that you multiply to get a number. So now we need to talk about how to find our greatest common factor, also known as your GCF. Okay, so we're given 3 numbers and we need to find their greatest common factor. So what you do is you need to first list what numbers are going to go into that. So I can multiply 1 and 4 to get 4, or 2 and 2. Then I list my factors for 12. 1 times 12, 2 times 6, or 3 times 4. And if you put them in ascending order, it makes it nice and easier later on to find what number is their greatest common factor. Then for 16, 1 and 16, 2 and 8, and 4 and 4. So as I look here, I'm like, hey, what do they have in common? Okay, well, start with the one with the least amount of numbers and see if this largest factor goes into the other. So if I look, I have a 4 here and a 4 here. So 4 is our greatest common factor. Okay, that's the number we're looking for. Okay, let's look at problem 2. We have 12, 18, and 9. So I go through and list my greatest common factors. Okay, numbers that I could multiply to get 12. 1, 2, 3, 4, 6, and 12. Put them in ascending order. Numbers you can multiply to get 18. Okay, 1, 2, 3, 6, 9, and 18. All of those numbers you could divide into 18 and get one of these other numbers. And then 9 only has 3 factors, 1, 3, and 9. So now we want to look and see which ones have the greatest number. So let's start. Let's see if 9 can go into all these. Well, there's a 9 here, a 9 there, but there's no 9 here. This is where it helps putting in ascending order. We can identify, oh, nope, it's not here. I don't have to go looking. So now let's go to the next one. I have a 3, there's a 3, and there's a 3. So we could say our greatest common factor is 3. Oops. Common factor. And we need to know this to be able to do the rest of our work. Okay? I'm going to challenge you to look and see, all right, what numbers can go into 22? Well, we know 1 and 22, obviously. Okay? Then I need to think, all right, it's an even number, so can 2 go into an even number? Yes, it can. So we have 2 and then 11. Notice how I'm trying to go, why did I put 2? I mean 3. My bad. There we go. Now it's a 2. Now 3 can't go into it, 4 can't go into it, 5 can't go. And if you have a multiplication chart to help you, you can look. Where do I see 22 in my multiplication chart and see what numbers are being multiplied? Okay, so that sums up that one. So let's now go to 8. Okay, so 8, what numbers could we use to go into 8? Okay, well, we know obviously 1 and 8. It's an even number, so 2 and then 4. Okay, what about 28? That one's got some different ones. Obviously, 1 goes into every number, so that's why we always start with that one. And I put the number itself at the end. What about 2? Is it an even number? Yes, it is. 2 and 14. And then if 3 can't go into it because they do not add up to a number that is a multiple of 3. What about 4? Yep, 4. 4 works. And 7. And then that's it. Those are the only factors that this one has. Okay, so now we need to look. Which number do they have in common? Take a second, look and see if you can find it. Okay, 2 is our greatest common factor. So if I was to divide all these by 2, it works. Okay, I'm going to challenge you. Go ahead and pause this video and look to see if you can finish this up without watching me do it. Four goes in the 1 time, so that is going to be 14. Half divided by 2, you get 28. All right, so we have found out for this one, our greatest common factor was 8. Okay. Fill that in, correct it if you need to. When we factor in math, we are finding the actual factors of the expression. We are looking for what was multiplied. Thus, we are on distributing what we are doing. So here we have two numbers and a variable basically are two terms, and we need to find out what is something they have in common that we could take out. Okay, so I want to find my greatest common factors of 6 and 10. Okay, so numbers that you can multiply to get 6, 1, 2, 3, and 6. This is why it was important to know how to find our greatest common factor, because it's going to help us with what we need to do. 1, 2, 5, and 10. Okay, so what do they have in common? They have our 2's in common. So I'm going to divide both of these by 2. Okay, so I take 6, divide it by 2 to get 3. Take 10, divide it by 2, and you get 5. That's all you're doing. You're just taking how we would normally start is what you're trying to come up with. They gave us the end result of using distributive property. We need to factor out that greatest common factor and put it back how it originally would look. Okay. Now what about 2? We have a -4 and a -16. Now remember, when you multiply two factors, one of them needs to be a negative. Okay, and since both of these are negative, I know my answer has got to be some type of negative number. So when I put my greatest common factors, I am looking for which ones that are negative, because then I'm going to factor that negative number out. Okay. Now, some of these you might know right away what your greatest common factor is if you're really good and know all of your multiplication numbers. Okay. Especially our lower even numbers. Those are a lot easier to figure out. Like I said, if you need to, use a multiplication chart to help you out. If multiplication is not your strength, use it as a tool to figure out what greatest common factor we have. So look, yes, they both have 2, but they have their greatest common factor is this -4. When I go up here, I'm taking out a -4. So -4 divided by -4 makes a 1. It's a positive 1. Remember, when you're multiplying or dividing with two negatives, you get a positive answer. Now that's why this has changed from addition or from subtraction to addition, because we are now dividing by a negative number. Okay, 16 divided by 4 is 4. All right, if you need to, pause it, fill it in. Okay, see if you can figure out 3 and 4 on your own and then come back to it if it's correct. Okay, let's look at this next one. Okay, we have a rectangle that has an area. Now remember, area is the inside, not perimeter, area of 4x plus 6. If the width is 2, what is the length? Okay, so we want to find out what this could be. Okay, so we know if we have a rectangle with the area, and to find area is length times width, and the area equals our 4x plus 6. With this 2 right there, it is telling us what we're factoring out. We need to factor out a 2 because my width is a 2. Okay, so I need to divide both of these by a 2. That is basically what you're doing, except it's set up differently. So when we rewrite this, we're going to put it this way and fill in our blanks. Okay, 2 can go into 4x twice. And then 2 goes into 6 3 times. So that means our length equals what's inside these parentheses. So our length is the 2x plus 3. That expression represents our length right here. Okay? So then let's look at number 6. Okay? A rectangle has an area of 9x minus 12. If the width is 3x minus 4, what is the length? So once again, we need to take out what kind of like the opposite of what we did with number 5. So my common factor that I have is going to be our width. And our common factor of both of these is 3. So that tells me our length is 3. That's your answer. Because I had to factor out what 9 and 12 had in common. Okay, so now I'm going to do a couple of these, and then I'm going to do the rest, and you come back and check your answers. Okay, you've got to learn to practice some of these on your own, and then find out if you did them correctly. Okay, so I need to look, what is my greatest common factor up here? So what numbers could I multiply What can I multiply to get 15? What is my greatest common factors? Well, 1, not even, but 3 can go into it because 3 times 5, and then 15. Okay, my greatest numbers that go into 10, 1, 2, 5, and 10. So we could say our greatest common factor is 5. Now that I found what my greatest common factor is, I need to go through and factor this 5 out of both my terms. So I know I'm going to have a 5 outside my parentheses. I'm going to have an x, an addition sign, another term, my end parentheses. I have to go in and fill these blanks now. So how many times does 5 go into 15? Well, 3 times. How many times does 5 go into 10? Twice. And that's it. You're done. That's your final answer. Okay? Sometimes we have some that we're going to find out are prime numbers. So a prime number is a number that has only 2 factors, 1 and itself. Okay? 7 and 3 are one of the first few prime numbers that we list. Right? 2, 3, 5, 7, 11, 13. Those are some of your first few primes. Okay? So if I don't have a number that's a multiple of either of the primes, then what we say is it cannot be factored. There's nothing I can do. This is already in its lowest terms. Okay? If I took a 1 out, I'm still going to have the same answer. Okay? So I'm going to encourage you to go ahead and practice doing the remaining 6 problems and then have them checked. I forgot to tell you guys, this 4x was extra. You don't need that 4x. So you're only factoring a 24x and 18. Okay, so both of those have a 6 that can go into both. Okay, 6 goes into 24 4 times, leaving the variable left over. 6 goes in 18 3 times. Okay, and then our greatest common factor here, 13 is a prime number. So 13 can't go into 18. So this cannot be factored. Okay, you check to see if you have your remaining answers correct. If not, double check your work, see what you might have done wrong. Okay, we have a square picture frame, has a perimeter. Okay, remember perimeter means you add up all the sides. Okay, what is the length of one side of the picture frame? How many sides are there in a square? Okay, that tells us right there that we need to divide by 4. Okay, because there are 4 sides. So if I take both of these and divide them by 4, that's going to give me my answer. That's its greatest common factor is a 4. So I have 4 outside my parentheses. So what's inside? Okay, I would have a 5x plus my 8, because 4 goes into 32 8 times. This right here is my answer. That tells me that one side of the picture frame is measured as 5x plus 8. Okay, remember with word problems, you should always restate the question. Okay, so now we have the rectangle shown below has a total area of 4x plus 36. We need to factor out 4x and 36. So when I look at this, I'm like, all right, what number can I take out of 4 and 36? They don't have the same variable, so I'm not going to worry about that there's a variable. Well, what's their greatest common factor? The greatest common factor is 4. When I go to factor, I'm going to take a 4 out. Now 4 goes into 4 one time, so it just leaves my x by itself. And then 4 goes into 36 9 times. And that is it. That's all they asked. Okay, if you need to glue this in, then we have some guided practice. Okay, let's find the greatest common factor of each monomial. Okay, that's what it's called when you have variables to the first power. There's no exponents included. Okay, so our first one, we just need to find our greatest common factor of 32 and 18. Okay, so what numbers could I multiply? Well, we could talk about how many times can 2 go into 32. Okay, that might help because 2 times 2 makes 4, right? We know 2 can go into there twice at least. And then 4 times 2, again, is 8. 8 times 2 is 16. 16 times 2 is my 32. This is how many 2's you would have to multiply. Okay, what about 18? What numbers do you multiply? Well, we multiply a 2 and a 9. So I'm going to break that 9 down some more into prime numbers. I'll break it down into 3 times 3. Okay, the only numbers they have in common is they both have only 1, 2. Okay, this is finding with prime factorization. Okay, if you want to, you can always look up, and it is in our textbook, I believe, about how to use prime factorization. You can use that to find your greatest common factor. Okay, so I would say up here, my greatest common factor is 2. Okay, all right, let's look at this one over here. We have 27S and 54ST. So numbers that we would multiply is 1, 3, 9, and 27. Not too many factors, even for being a larger number. But what about 54? Well, I know 1, the even number, so 2 has to go into it. 5 plus 4 makes 9, so 3 has to go into it. Okay, 4 can't, 5 can't, 6 goes into it. 6 can go into it 9 times. Okay. So then now I notice my numbers are getting a little bit bigger. So I'm going to start. Well, what is half of 54? Well, half of 54 would be 17. Okay. Then I know half 3 goes into 54 with 2 left over, so 18 times. Okay. That's where we're at. There's not really much more that they would have in common. So I can already tell because of this 9. Now, this one has something different than most of the others have had. Okay. There are variables they have in common. So when I look at this, I'm like, ooh, what variable do I have in common? You notice they both have an S in them. So I technically can factor out a 9S. You can take both of those out of those. Okay? So let's now look at 3. Right? Numbers that 18 and 30 have in common. Well, 18 can't go into it. Half of 18 is 9. 9 can't go. 6. I can take a 6 out of both of these. Okay. And what about variables? Do they have any variables in common? Well, they both have a C. What about D? Do they both have a D? Yes, they do. So we can technically factor out a 6C D. 6 times C times D. Okay. All right. So next we have factor each expression. If the expression cannot be factored, right cannot be factored. If we need to, we can use algebra tiles. That is meaning you can model it out. Okay. So I'm going to look, I'm like, all right, what can I take out of 36x and 24? They don't have the same variable. So I know I'm going to keep my x in there. Okay. So I'm going to have something on the outside of these plus my x plus something else in another parentheses. So what would go out? Well, 36 and 24 have the greatest common factor of 6. Okay. 6 can go into 36 6 times. Ooh, they might have something even more. They have something more. I would have listed this out. I would have noticed 12. 12 goes into 36 3 times, and 12 goes into 24 twice. The reason why I noticed I didn't have the greatest common factor is because I had 2 even numbers in here when I first started with the 6. Okay. What about 5? Well, let's look. I have 4. What numbers can go into 4? So I don't make another mistake doing this. We have 1, 2, 4. Numbers that go into 9? 1, 3, 9. Don't have anything in common. So we're just going to say cannot be factored. That's it. Done. Okay, 14 and 16. Numbers we multiply for 14. 1, 2, 7. Now obviously 14. 16. 1, 2, because it's even. 4 times 4. 8 times 2. And 16 times 1. Greatest common factor is a 2. So 2 is going to go outside our parentheses. 2 goes into 14 7 times. keep our subtraction sign because I'm not factoring out a negative. And then turn this into an 8y. I couldn't take a variable out because both of these terms did not have the same variable. Okay. Mr. Penn's monthly income can be represented by the expression 25x plus 120, where x is the number of hours worked. We need to factor what is our greatest common factor of 25x and 120. Well, let me think here. 25 only has 3 factors, 1, 5, and 25. And 25 cannot go into 120. So I'm going to use 5 as my factor, get my 5x plus, and then 5 goes into 120, okay, goes into it 24 times. Okay, we need to recheck your work. Okay, take 5 times 5x, you get your 25. Take 5 times 24, and yes, I get 120. Okay, explain how the greatest common factor is used to factor the expression. Use the term distributive property in your response. Say is that the distributive property shows that A times the sum of B and C equals A times B plus A and C. The greatest common factor, being the A, is the number that's being distributed to each term inside the parentheses. Okay, let's talk about homework. Okay, your homework is 1 through 14 and 17. It's only 15 problems. Okay, notice it always tells you where you can find examples to help you. Okay, when you go through it, make sure you are looking for what your greatest common factors are. Okay, if you are still watching this video and you are in Mrs. Oliver's class, put a star above this house for an extra point for watching your video all the way. Okay? We need to know the greatest common factor of 36 and 144. Nope. Scratch that. I just rechecked. Our greatest common factor is 36. Then we gotta look for variables. Do they both have a K? Yes. So 36K. What about M? I have an M here, but do I have an M there? Nope. So 36K is my last one. When you normally have large numbers like this, it always helps to see, okay, can 36 go into 144? Well, 36 times 4 is 144. Okay? All right. Finish this up and have a great rest of your day.